Lysandra, I've got an electric sharpener right here. There you go, sir. All right. So, I can statement. Our I can statement is, you guys just hopefully glued those into your journal. Whoops, that's kind of large. I can write equations in. All right. Kylie, I want you to move over to that table right there, the tall one by the door. In standard form and point slope form. Thank you, ma'am. I can write equations in standard form and point slope form. So basically, we're going to learn two new forms, two new ways to write linear equations. So you already know the first form, slope-intercept form. Slope-intercept form is y equals mx plus b, where m is what? Slope. M is the slope. How do I find the slope if I'm given two ordered pairs? Good morning, sir. How are you doing? How can I find the slope if I'm given two ordered pairs? I would look in my journal. You guys did that. That's the equation, y equals mx plus b. That's slope-intercept form. I'm trying to just find slope from two ordered pairs. How do I find slope from two ordered pairs? Good job, Tim. Yeah, slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's important. We have to remember how to do that, okay? What does B stand for? Good job. B is the y-intercept. What do we know about the y-intercept? Mm-hmm. What else do we know about it? Good job. Happens when x equals 0. That's important. I want you to add that. It happens when x equals 0. Okay. So the two new forms that we're going to learn today are standard form and point slope form. Standard form, ax plus by equals c. Do you guys notice that the a, the b, and the c are all capital letters? A, B, and C are integers. That means they're not fractions and they're not decimals. And both A and B cannot be 0. And we also like that A is positive. We like A to be positive. Okay. And then point slope form, probably one of my most favorite ways to write a linear equation. Y minus y sub 1 equals m times the quantity x minus x sub 1, where m is our slope. And the x sub 1, y sub 1 is a given ordered pair. The x sub 1, y sub 1 is a given ordered pair. I am going to highlight the two new forms. So standard form and point slope form. Because they're important. So this whole lesson today is just using standard form and point slope form. Raise your hand if you need more time with that. Okay. So example number 1, write the equations in standard form. So I'm going to write off to the side what standard form is. Remember, standard form is capital A, X plus capital B, Y equals C. That's the form that I want, meaning that I want the X and the Y on the same side and the constant on the other side of the equal sign. Okay. So I have a parenthesis in this first equation. How do I get rid of parentheses? Distribute. Yeah, good job. So the first thing that I need to do is distribute. And I'm just going to write DIST for distribute. So I'm going to distribute. So I have y minus 2 equals, well, let's see, negative 3 halves times x is just that, negative 3 halves x. And negative, I'm going to write plus, and then we'll put this off to the side. Remember, this 4 is over 1. That's the same thing as 4 over 1. And we multiply fractions straight across. So negative 3 times 4 is negative 12. And 2 times 1 is 2. Okay. So the problem with this is that I have fractions. I need to get rid of the fractions. How am I going to do that? Because I can't have any fractions for standard form. Not divide, because they don't all divide nicely. Can't have fractions or decimals. No, because the 3 halves x is a variable term. And it, very good. No. Yeah, but do you guys see that negative 3 halves? Negative 3 halves is a decimal when I try to simplify that. Do you see that? So I have to get rid of the fractions. How do I get rid of a denominator? How do I get rid of a fraction, Owen?
By multiplying it by the denominator.
Yes. So we have to multiply everything. We have to multiply. Ooh, wait a second. That's too thick. We have to multiply all terms by 2, which is our denominator. So I'm just going to kind of draw some arrows so you can see that I'm multiplying every single term by 2. So let's see. 2 times y is 2y. 2 times negative 2 is negative 4. 2 times negative 3 halves x is, well, the reason we multiply by 2 is the 2 in the numerator cancels out the 2 in the denominator. So that just leaves me with negative 3 halves x. And 2 times negative 12 over 2 is just negative 12. Because again, the 2 cancels out the 2 in the denominator. So now I have to get my x and y on one side and my constants on the other side of the equal sign. What do you want to move first, Owen?
I'd like to move the 4.
Okay, so how am I going to
Add
cancel?
4 on both sides.
Good job. Add 4 on both sides. So 2y equals negative 3x. And let's see, negative 12 plus 4 is negative 8. What would you like to do next? Anyone? I need to get the x and the y on the same side. Lissandro. I need to get the x and the y on the same side. I need to get the x and the y on the same side. Are they both on the same side of the equal sign right now? What? We just moved the 4 over to the other side. What do I need to move? What do I need on the same side? I need the x and the y on the same side. So right now I have the y. I need to move the x over there. I would add 3x to both sides. Good job. Add 3x to both sides. So 3x, this 2y is positive, so plus 2y equals -8. Ax, that means a is 3, plus by, b is 2, equals c. C is -8. Are 3, 2, and -8 all integers? Yes, they are. Okay, so we've done that. We've put equation A into standard form. Okay, now let's take a look at example B. Example B. So I don't have any parentheses. I don't have to do any distributing right off the bat, but I do have a fraction. How am I going to get rid of the fraction?
Multiply it by 3.
Good. So I'm going to write get rid of fraction by multiplying every term by 3. Every term gets multiplied by 3. So let's see. I'm going to put my 3 right over here. I'm going to distribute this way. Draw my arrows this way. So what is 3 times y?
Did you say we were doing that check-in Wednesday?
Wednesday, yes, sir. You're so welcome. What is 3 times y? 3y. And 2/3 x times 3. Remember that the whole number 3 gets rid of the denominator 3, because really this is 3 over 1. A denominator and a numerator of the same value when you multiply cancel each other out. So the 3's cancel out, and I'm just left with 2x. 3 times -5 is -15. Okay. So now what would you like to do? I need to get x and y on the same side. Owen.
Add 2x.
That is a positive 2x. So if I add 2, it's going to give me a 4x. I'm going to subtract it. I'm going to subtract 2x from both sides. So -2x plus 3y equals -15. So remember, we like A to be positive. How am I going to make A positive? What is something that I can multiply everything by to change the sign but doesn't change the value? Think of it like this. What if I had a negative x? If I had negative x equals 4, what would you do to both sides? No. Huh? No. If I wanted to solve for x, and that's a negative x, how would I get rid of that? Multiply both sides by -1, right? So that's exactly what I'm going to do. I need to multiply this whole equation by -1. So -1 times -2x plus 3y equals -15. So when I do that, let's see, -1 times a -2x gives me a positive 2x. -1 times a positive 3y gives me a -3y. And -1 times a -15 gives me a positive 15. So this is the standard form of equation B. Raise your hand if you need more time writing that down. Good? Okay. All right. So we can actually graph an equation using standard form. I call it the cover-up method. You find the x-intercept and the y-intercept. So remember, The graph crosses the x-axis when y equals 0, and the graph crosses the y-axis when x equals 0. So if we're going to graph these two equations, we want to find the x-intercept first. We're going to find the x-intercept, and that just means that we let y equal 0. So let's see, that's 2x plus 4 times 0 equals negative 12. But what is 4 times 0?
0.
So I really just have 2x equals negative 12, which means x equals what?
Negative 6.
X equals negative 6. So this is the ordered pair negative 6, comma, what did we let y equal? 0. That's our first ordered pair that we can graph. Now I want to find the y-intercept. And I know the y-intercept happens when x equals 0. So I have 2 times 0 plus 4y equals negative 12. But what is 2 times 0? 0. So I really have 4y equals negative 12, which means y equals, when I divide both sides by 4, right? I'm dividing both, negative 3. Y equals negative 3. So this is the ordered pair 0, comma, negative 3. So let's go ahead and just plot those two ordered pairs. Let's see, negative 6, 0 is this point, and 0, negative 3 is this point. So if I wanted to graph this equation, 2x plus 4y equals negative 12, I call it using the intercept or the cover-up method. This is my graph. This is my graph. Okay, so I want to tell you why I call it the cover-up method. Here's why I call it the cover-up method. If I want to find the x-intercept, I have to let y equal 0, so I just cover it up. What equation do I have now?
You have 3x equals 18.
Yeah, you have 3x equals 18, which means x equals what?
6.
So that's the ordered pair 6, comma 0. If I want to find the y-intercept, I have to cover up the x. So I just cover it up. I use my finger and I cover it up. I cover it up with my finger. On the screen, I'm covering it up by just scribbling it out. What equation do I have here? Yeah, negative 6y equals 18. That means that y equals, what's negative 3. So this is the ordered pair 0, comma, negative 3. So I can plot those two ordered pairs. Let's see, 6, comma 0 and 0, negative 3. There I go. Okay. So I call it the cover-up method because if I want to find the x-intercept, I cover up the y term with my finger. If I want to find the y-intercept, I cover up the x term with my finger. That only works if it's in standard form. If it's not in standard form, it doesn't work. Okay? Questions about that? Do we need more time on number 3, on this example? Got it. Good. Okay. All right. Now we're going to write an equation in standard form to model the given scenario. So going to write out what standard form is again. So if I'm going to write an equation in standard form, that means I have two variables. Let's see. Devin bought 3 cartons of eggs and 5 pounds of apples for a total of $15.95. So I'm going to let X equal the cost of a carton of eggs. It's not the number of eggs because I already know I'm buying 3 cartons. And then I'm going to let Y equal the what? What's the Y term going to be? What else am I buying? I'm buying eggs and what? Apples. How are the apples being measured? By the what? By the pound. So I'm going to let Y equal the cost of a pound of eggs. Of apples. So how many cartons of eggs did I buy? So 3 times the cost. 3 times the cost of 1 carton, which is X, plus how many pounds of apples did I buy? 5 times the cost of 1 pound of apple equals, doesn't equal Y, it equals the total money, right? $15.95. Do I need those parentheses around the X and the Y? No, I don't. So I'm just going to rewrite it so you can see it. 3X plus 5Y equals $15.95. This is going to be useful because we're starting systems of equations on Wednesday, and a lot of our word problems for systems are written in standard form. A lot of our word problems for systems are written in standard form. So it's important to know how to write them, okay? Raise your hand if you need more time with that. All right, let's go to example number 4. So example number 4 is graphing an equation that's written in point slope form. So you guys are going to be angry when you find this out, but if you're given an ordered pair and you're given the slope of a line, you can actually write an equation without finding the y-intercept. You just put it in point slope form. So remember, point slope form, y minus y sub 1 equals m times x minus x sub 1. So I need to find out my slope and I need to find my ordered pair. That's what I need to find. But I want my equation, I want this equation right here to look like this equation right here. And it doesn't. What's the problem with it? Slope can be a fraction. The problem is really right here. When I look at this compared to this. It's important to know where that plus sign came from. And that plus sign came from minus a negative. So y minus 2 doesn't change. Negative 3/4 doesn't change. But in the quantity, I really have x minus the x sub 1 term. And when we do minus a negative, we actually instinctively turn that into a plus. So that means that this is the x1 coordinate and this is the y sub 1 coordinate. Do you guys see that? If you don't turn it into that whole minus a negative, you might not see that it's actually a negative number when you leave it as a plus. So what is my ordered pair? What is the x sub 1, y sub 1 term? What's the ordered pair?
It's -1, -2.
Negative 1, negative 2. What is my slope? What is my slope? Hang on a second. Hang on. It's not -1, -2. I need to stop. So the equation is written as y minus the y sub 1 coordinate and x minus the x sub 1 coordinate. So what is y sub 1 really? It's a +2. Okay. And my slope is -3/4. My slope is -3/4. So when we want to graph this, we actually begin with the ordered pair. And then you count your slope. So we're going to start at the point -1, +2. We're going to start at the point -1, +2. And then we count a slope of -3/4, which means that I go down 3 and to the right 4. Down 1, 2, 3, to the right 1, 2, 3, 4. I can try that one more time. Down 1, 2, 3, to the right 1, 2, 3, 4. I'm going to go off my graph 1 unit. I can also go up 1, 2, 3, and to the left 1, 2, 3, 4. So my graph looks like this. So it's important to realize that the equation in point slope form is y minus the y1 coordinate and x minus the x1 coordinate, okay? Raise your hand if you need more time with that. Okay, so let's look at this next example. Again, we know that we're going to need an ordered pair, and we're going to need to find our slope. So does this equation, y plus 5 equals 4/5 times the quantity x minus 2, does it look like the equation up top? Y minus y sub 1 equals m times the quantity x minus x sub 1. Is there a y minus there? No, there is not. We need to rewrite it. We need this to say y minus. So what does the sign have to be to have this turn into a plus? Well, it's got to be a -5. Do you guys see that minus a negative automatically turns it into a positive? So you have to realize that when you see a plus in this form of an equation, it really came from a -5, okay? Equals 4/5 times x minus 2. So I have a y minus the y sub 1 term, and I have an x minus the x sub 1 term. So what are my ordered, what are the coordinates for my ordered pair, Ken? What is x sub 1 and y sub 1? X sub 1 comes first. 2 and 2 comma -5. Good job. What is my slope, Lissandro? Wrong equation. We're on the next one. Keep your eyes awake. What is the slope?
Oh, 4/5.
Not x, just 4/5. 4/5. Do you see your slope right here? There's no x attached to that, right? It's just the number 4/5. So where do I begin? Where do I begin, Kenna? I begin where? Okay, so what point? So I'm going to begin at the ordered pair, which is +2, -5. And then what do I do? Ariana? What do I do? Yes, ma'am. Then you count your slope. We're going to go up 4 and to the right 5. Up 1, 2, 3, 4, to the right 1, 2, 3, 4, 5. This one actually goes off of our graph. Okay. Raise your hand if you need more time with that. All right, for our last example, we're going to write an equation in point slope form to model this scenario. So point slope form, y minus the y sub 1 coordinate equals my slope times the quantity x minus the x sub 1 coordinate. So I'm basically trying to find the slope and an ordered pair in this equation. I'm looking for the slope and an ordered pair in this verbal statement. So it says Eliza deposits $25 each week. What happens when we see that word each? We know that that's what kind of word? It's a slope word. This is a slope word. So what is my slope? It's 25. Okay. It says after she deposits $25 each week into her savings account. After 12 weeks, she had $650. After 12 weeks, so I have number of weeks, total amount of money. That's my ordered pair. Number of weeks, 12, total amount of money, $650. Number of weeks, 12, total amount of money, $650. So I need to define my variables. X is going to be the number of weeks, and Y is the money in savings. X is the number of weeks, and Y is the amount of money in my savings. So let's write an equation. What's my equation going to look like? Remember, I'm trying to make it look like this. Y minus Y sub 1 equals M times the quantity X minus X sub 1. The things that get changed are the Y sub 1, the M, and the X sub 1. So what can we plug in to write our equation? So tell me what I'm going to write. What does that equation start with? Starts with a Y. Do you see that? Y minus, what is the Y1 coordinate? You said it. 650 equals M, which is my slope. What is my slope? 25 times the quantity X minus X sub 1. What is X sub 1? Yeah, your ordered pair is an X sub 1, Y sub 1. So X minus 12. This is our equation in point slope form. This is our equation in point slope form. Lissandro, I want you to come stand right here. What did I tell you? I talked about that at the very beginning. Bring your stuff over. Okay, so the question is, how much money did Eliza start with in her savings account? So if I'm just now starting my savings account, what time is that? What is the value of X? Like when I just begin. Yeah, at the beginning, X equals 0. So I'm going to use the idea that X equals 0. And I'm going to plug that in right there. and figure out how much money she started with, which is your y-intercept. Okay, so let's do that. I have y minus 650 equals 25 times 0 minus 12. Well, what is 0 minus 12? No, it is not. It is negative 12. So y minus 650 equals 25 times negative 12. What is 25 times negative 12? You all have calculators sitting on your desk. Shouldn't just be one person using it. Owen, negative 300. So y minus 650 equals negative 300. Trying to find the amount of money in my savings account. Y. Trying to get y all by itself. What do I need to do next? Add what, hon? Yes, ma'am. Add 650 to both sides. So y equals 350. So how much money did Eliza start with? Yeah, Eliza started with 350 in her savings. Eliza started with 350 in her savings.